Hey guys, what's up? Welcome to another video. I hope you guys have been doing well with whatever personal projects you have been working on. If you have learned something, anything, if you're facing something issue regarding whatever projects you're dealing with lately, I think it's safe enough to say that you can put it down in the comment section there will be someone out here who can definitely help you out. And if you do well, very well with it, they'll go for whatever allow you for their permission to help you out with. With that said, let me come to the main purpose of this video. So, I wanted to talk about a recent event which I have been a part of, and it's called EV Challenge. So, first of all, what is this EV Challenge event? So, this is an event which is organized by IPG, yes, in collaboration with Bosch. So, in this event, we dealt with the simulated environments, simulated testings. Okay, we had to develop controllers basically for a simulated car, and basically improve our understanding of the car maker product. That is, the basic level, most simplest way of explaining to you what this event was all about. But for me personally, more than just understanding what car maker was about, this was a project based learning. Okay, so initially they'll give you some task, you have to complete it, and you have to submit it based on the results which you have been putting out from that particular model. They will evaluate you and push you further for next stages. And I'm happy to tell you that we are able to clear further and further stages, and we won the first runner up for this event. Okay, that was uh, totally great event, a crazy moment for us, because a lot of planning, a lot of meetings, a lot of overtime, I would say, went for this particular event as well. So without further ado, I'll just give you like, first let's talk about what are the tech stack which we dealt with, what are the different phases involved in the event, and kind of get you our strategy, what we tried to implement for this particular event. Okay, so here we go. So first of all, the tech stack which we dealt for this event, uh, we had to deal with something called as an FMI, or a functional mockup interface. Okay, if you don't know what an FMI is, I have previously made a video on it on my channel. You can definitely go check that out. You can also find more complex, more better understanding videos, which I can link them down below. But apart from that, uh, FMI concept was used in this particular project for the development of a controller, basically a controller model which can be utilized multiple number of times, not just in the car maker environment but in any other simulated environment, regardless of what type of internal architecture it uses. FMI is a standard which is being adapted by many different organizations, even MATLAB, NVIDIA, Open Modelica, you name it. Okay, so they have support for FMI, so you can definitely implement it over there. So using this FMI concept, we built a controller module which controls the simulated car to move in the simulated environment with the least amount of SOC usage. So we had a particular track set up for us in the environment. We had to cover that distance with the least amount of SOC being used. This may sound simple, that okay, since you have to cover the distance in the least SOC, we could identify what is the uh, ideal or most efficient speed for the vehicle. Then we'll run the car in the same speed throughout the track. No. It does not. It does not work like that, because this was an actual simulated track which represented the highway between Pune and Bangalore. Okay, so whatever artifacts you'll get, or whatever kind of attributes you'll get in the real world for this particular path, that had been replicated down here in the simulated environment as well. So it's not that you'll have a straight path always. You can have some bumps coming up. You can have some potholes. You can have ups and downs. Okay, highways, flyovers. Okay, and even more constricted paths coming in. So our strategy should be such that the acceleration and deceleration should be happening in such a way that the battery is affected in a very minimal manner. Okay, one thing you have to know about any EV vehicle. In fact, I haven't told you before. This was an EV vehicle competition. So the EV vehicle which you are simulating, uh, it had one particular characteristics that you cannot have too much acceleration or deceleration happening in the car. So you cannot be like, I'll press the throttle too much or brake too much in, a oscillating manner. You cannot do that, because that will suck out the battery to a certain extent that you'll be overall losing your battery and it will be wasted throughout the whole journey. Instead, we had to smoothen out those curves. Okay, so wherever acceleration and deceleration are required, uh, we had to do it in a way that it was very smooth. Okay, we should not do like, constant braking or constant accelerating, off the pedal, on the pedal, nothing like that. We have to do it in a very smooth and efficient manner as possible. So initially they had given us like a base FMI. Okay, they had told us you can work on it or we can adapt our own ones. But we decided that we'll build our own ones based on whatever reference they have given us. And initially we were ending up with close to 1% SOC at the end of the whole track. So 153 kilometer of simulated track, we cleared it with just 1% or close to 1% SOC at the end. Okay, initially, but slowly, through adding more filter blocks, through adding more PID controller blocks to further tuning, we are able to bring that number up from 1% to 36%. So huge improvements. So that was phase one. Okay, build an efficient controller. And because of our efforts, because of our team effort, I would say, we are able to clear that phase out, and we are able to move to phase two. Now, phase two was all about agentic implementation. So I told you this event was held by IPG and BOSCH, right? Now there was also a third key partner coming in, which was called Fetch AI. Okay, so Fetch AI had their AI agents coming into picture over here. What we had to do was develop, modify our controller in a way that when the SOC hits a particular threshold, like say 25 or 30, it's all left up to you. We chose 25. So when the SOC drops to 25 and below, that time it will raise a charging request. Okay, so when this charging request is raised, this charging request is sent to an external agent. So initially the FMI was built in MATLAB. We used to bring that down to car maker, set the inputs and outputs, then we used to simulate, right? That was phase one. Now in phase two, we used to not just deal with only the simulation environment, but we also used to send some signals out, okay, from the simulation environment also. For that, we had to use Python scripts. So we had some car maker scripts running in the background. So that car maker script would monitor all the internal variables of car maker environment. So if you did not know, car maker has its own module. So car maker module you can import in Python and then you can run it off. You can definitely check that out also. So we used to monitor all the variables. One was SOC, one was the distance traveled by the car, and based on the SOC, we used to set a boolean condition that when the SOC goes below 25, charging request should be raised, and this request is sent out to another script. So we have car maker script and another external agent or a script. Okay, so this is the AI agent. This is supposed to be the AI agent, but phase two was bit of a confusion actually, because none of us really understood how to bring the AI agent to the picture over here, because there's not a lot of learning materials available. Documentation is there, but that wasn't really helpful for us to understand how to implement it for our use case. So what we did was that instead of having the AI agent working with our car maker script, we built our own Python script for that also. So car maker script will send the charging request. So again, so initially we had this car maker environment running in the background. We had this car maker script running parallelly, and this car maker script would monitor the car maker environment variables. So when the SOC reaches a certain threshold, we had another script which was supposed to be the AI agent, but we are not able to implement it. So built our own script. So this script was acting as a station master, which had data of all the stations, and we used we used to send the charging request based on whichever are the reachable stations. So we had, I told you right, we had distance and SOC as the variables being monitored. Based on that, we used to estimate the range. Okay, easy calculation. Based on that range, whichever is the reachable station, so which stations come within that range, for those stations we used to raise the charging request. So this station master then used to see, okay, if any other team or any other car has raised charging request for those particular stations or not. If anyone has raised charging request for those particular stations, then those we would not get. But whichever station is free, okay, whichever station is free, for those particular station, we used to get back a response saying, see, success, this particular station has been allotted to you. Okay, and that is the station which for which we used to send our car to. Okay, so we used to send a car to that particular station, and it used to get charged. Over there also we used to set our SOC. Okay, like to what percentage SOC we need to charge our car. So it's not that we will need to charge our vehicle to a full 100%, right? So based on the remaining distance from that particular station to the destination, what's the distance which is remaining for that particular station, how much SOC is required, only that much amount we used to charge. Once that amount is charged, then we used to move to the charging station and continue on our journey. Okay, it's not we would not used to get the exact value like how much we would exactly need to cover the distance, but we used to make average calculations or assumptions that saying that if we are able to calculate our mileage based on distance and SOC, then of course we can also estimate the how much charge would require to cover the next set of distance based on that mileage term itself, right? So that's how we used to estimate, okay, this much amount of charge is required, and that's the charge limit we used to set for that particular station. And once the station is once the charge is out, we used to move to the station and continue our journey back again. So that was how phase two went. We presented our work to the judges, and even they were also asking about the agentic implementation part, but we said we tried our best, but we couldn't do it. But anyways, we were tensed, but somehow we cleared that phase two also. Okay, because many other teams also could not do it, because even they faced difficulties. But okay, fine, we did it. Phase three, my god, that was the most intense work, because right now it was similar to phase two. Okay, we used to still raise a charging request and all those stuff, but this time we do not have to worry about the AI agent. That is taken care by IPG itself. Okay, our work was to only determine like what is a token. So this time an additional factor came in was tokens, how much tokens has to be raised for each station. So now, along with raising the charging request for each station in phase 3, we also had to raise a particular amount of tokens. So each station had a base token. Okay, like station 3 had like say 9 tokens, station 4 had 10 tokens, station 5 had 12 tokens. Okay, so on and so forth. What we had to do was, basically we know this base tokens, right? For per 10% of charge, this much is the base token. If say we are charging our car to another additional 40%, okay, 40% amount of charge we are charging, then for that particular station, what will be the base charge? Like say if the base charge is 12, 10 for 10%, then for 40%, how much it would be? So times 4, which would be 48. Yeah, 48 tokens would be charged from us. And we used to give so much amount of tokens, and if the station master from the IPG side used to tell us, okay, see, you have raised so much tokens, but there is other team also which is giving me so much tokens as well. Then we will have a negotiation happening. So it's like um, we'll have to raise an additional amount of tokens. If they are giving 48 tokens, we are also giving 48 tokens. We used to give 48 plus 5, saying, see, we are giving more number of tokens. Or say, even if the negotiation does not work out, then the station master itself would decide, okay, that which of you has the lowest SOC. For that, I'll give preference. Okay, based on that, we'll assign us the charging slots. So that's how phase 3 was going on. Okay, and for phase 3 we had to be present in IPG office. So the IPG office comes somewhere close to Yeshwant, no, Yeshwantpur side. We had to go to their office. We had to present. We had to put our simulated models, what we have developed so far for the past 3 to 4 months. It has been 4 months since we have developed this model. We had to bring this model to IPG office along with the rest of the teams. Okay, so there were 3 teams finalized. All 3 teams came to IPG office. We had to set up the IPG car maker also, and each of our environments are different, right? We cannot do like a simultaneous test for all of us. So IPG themselves had created one test platform where all the simulated environments will be running together.
But you do it only after charging is complete. Yes.
Okay, so we had a dashboard where you can check our SOC, how much tokens was being consumed, how much SOC is, yeah, like how much distance was covered, how much SOC is remaining, uh, and like there's many different factors. So I mean, you can also see the leaderboard, like who is at the top one, who is top two, top three, like that. So we did our best, okay, even for phase 3 also. So the strategy what we had gone with for phase 2, similar strategy was implemented over here also. Little bit tweaking here and there, like say, if initially if you raise a charging request for one station, and if a charging request gets rejected, we would not stop there. Okay, we would raise another charging request. Okay, if we didn't get charging station request for I mean response for station 1, say, we'll raise charging request for station 2. Okay, the request 1 did not get accepted. Station 2 is there, we can raise it over there. Station 2 did not get accepted. Station 3, station 4, station 5. And if it did not get accepted again, we'll repeat the loop once again. So station 2, station 3, station 4, station 1. So on and so forth. You get the point. So that's how we continued further. Okay. And we did it. In the initial few runs, we were pretty confident that we will get the first place because we were efficient. Okay, we were very efficient in our controller. We did not let our SOC drop below 25 also, not at all. The other teams, they were just going like Formula One. Everyone, even the judges were saying the same thing. They were going like Formula One only. Everyone is going at top speeds. We had clamped our speeds. Okay, so at the initial phases, we thought it's not better to waste our SOC because we had observed this during our simulated runs also, that the SOC is draining very quickly during the initial first half of the track. So we had clamped our speed itself, that for this particular distance we'll run for 20 kilometer per hour, then we'll go for 30, then 40, then 50, and then higher values. But other teams, they just went straight off with top speeds, 80 kilometer per hour, 70 kilometer per hour. Okay, that was actually the ideal value which we also had to set, but we were not able to identify how to do it. So yeah, like I said, few minutes, initial first half of the day, we are like we will win, but in the final run, they told all the teams to have one final tweak. Okay, you can do whatever tweaks you want. We were confident, so we did not try to change much. Okay, just a few inputs, parameters changed here and there, but nothing too significant. The other teams, they noticed how they were going too fast and they were draining SOC very quickly, somewhere even with 10%, 5% SOC. And let me tell you, if you went below 10%, if you went below 20% SOC, you had to have penalty. You'll be penalized for it. We were not penalized, they were penalized. So they worked on their FME models once again. They improved on their mistakes and they put it forward. Okay, the one team which was going at this top speeds, they were also able to figure out how to not go below the certain SOC also, while also getting a decent amount of charge and cover the whole distance. We were not able to do that. So I mean, we have put our sincere efforts forward, but we were not able to figure out how to do that. So we lost on that part. but in terms of efficiency we got full marks, so I'm happy about that part. We had to figure out how to go with the efficient speed, but that wasn't done. So yeah, that's how the day went at IPG office. On the same next day, we had the ET Auto Mobility Summit. Okay, so it is a automotive tech summit. Okay, if you have heard Bangalore Tech Summit, this is also some similar summit. Again, this was all funded by IPG itself for all the finalists. It was held at Taj Hotel, and we had all these delegates. Very influential persons, VPs, CTOs, CEOs, you name them from any company. Yeah, be it Mahindra, be it Maruti Suzuki, be it KPIT, Bosch, IPG, all, both our delegates from our country as well as international candidates, even they were present. And we were sitting in a room. Okay, all the finalists were sitting in a room. We reran our simulation once again, just for demonstration of our work in front of all these important persons. They looked at our work and they were congratulating us for coming out so far, and putting out such efforts on understanding the whole process, on understanding how to develop such systems. So we really built good connections over there as well. And I think that is also a part where we have to improve, right? Getting good connections out of any event. Okay, so of course, one part that is not there. So they had told us that if you have anything in mind regarding any projects, just reach out to us. We can help you. So really grateful for those people once again. So yeah, at the end of the day, after talking to all these people, the results were declared. We got second runner up, and we were over the roof for that one. Still, still somewhere it hurts that we didn't get the first place, but yeah, the event went very well. We are terrific event. So yeah, and that's it for the whole video, I guess. So I spoke to you about the entire stuff what you have done throughout this event. Okay, like what was phase 1, phase 2, phase 3, how the development went, what tech stack we used, what we talked about. My god, it was so fun. Okay, next year I am pretty sure EV challenge is gonna come once again in India, probably in the month of June, July. I think June or July, probably July 14th was the day we registered. So around June, July, you'll get this event coming up. So if you guys are interested, based on whatever I have said so far, you will be so much more interested if you are gonna actually participate in that event. So definitely go check that event out. Okay, next year, June, July event time, just check that event out. If I get the link of that event once again, I'll just post it forward in our YouTube community itself. You can check it, or on my Instagram page, which I'll give a link into. So yeah, if you guys have any more queries, any more doubts to ask about this, or any more suggestions to give me regarding whatever process I have told you so far, I'm free to listen to them. Put it down in the comments. We will talk, and that's it. Until then, see ya. Hope you guys do well.